Good day and welcome. Thank you for joining me. I am not making Carbonite, but I am going to show you how I built this Carbonite control panel fully from scratch. This was a large project befitting a departure from my normal style of video, which I enjoy, but they do fail to offer much insight into any techniques I use. I am not claiming to be an expert, I'm just going to show you how I go about these projects. Like most projects, this one began as an idea arising from the depths of my thoughts as I slept. I thought, wouldn't it be nice to build a Carbonite control panel? I want that. It's complicated enough and challenging enough. It would be glorious. A peace comes over me as I've not felt before. If I could pull it off, it would be marvelous. There would be world peace. I'd be the most popular kid in school. But then I awakened to the cruel reality. A severe truth that I cannot hold this in my hands grounds me harshly. My dreams, once more, are dashed. But the idea has taken hold. One which shall grow to consume my thoughts, drive my being, and become a goal to which I am irresistibly and hopelessly drawn for this month. I begin by preparing and consuming an appropriate amount of coffee, then scour the internet for reference. Many of you know this is a dashboard from a 1978 Volvo, no longer available. Being what it is, many people have built their replicas and have done some excellent work, but there is an absolute mess of information out there and very little on actual dimensions. I was able to find the overall length. However, every so often, you realize some golden info is staring you right in the face if you only connect the dots. In this case, it was literally. I found an excellent close-up photo, nearly orthogonal, which just struck me. It has this stuff, prototyping perf board. I call these everyday items in reference photos real-life rulers. The holes are exactly 2.54 millimeters apart in orthogonal directions. Or for those of you who enjoy the imperial system, that's 2.54 millimeters worth of inches. With that info, I was able to model this. I used that in turn to determine this shape with confident accuracy, and then this shape and the relative distance from each other, and then this, and this. And then after a caffeine-fueled design blitz, I was able to arrive at this. I make no claims of accuracy, and I'm pretty sure there are errors, but I am quite happy with it. This will serve my purpose, and while it's not perfect, it's good enough for government work. I have found designing this to be one of the most enjoyable parts of each project. If you've noticed, I always start with the CAD design. A good design means a good build. I've color-coded the various parts according to how I'll fabricate them. There are sticker cuts, laser cuts, filament 3D prints, resin 3D prints, styrene bits, thick acrylic, thin acrylic. On the actual Volvo dash, there are pin marks in the injection molding process. I wanted to replicate those, so I used my beloved sticker cutter to cut some paint mask. I don't think it's vinyl, like most stickers or decals would be cut from. But I like this because I can actually bond to it with solvents like Weldon 3. I'm going to stick this to some 0.5 millimeter styrene sheet. This is a tack cloth that I use to remove any dust from the surface. If you've watched my other videos, you may have noticed my shop is shockingly dusty. I should have taped down one end here, but it's working. I'll roll out the invariably trapped air bubbles. Results are more often surprising than successful. Then there's the tedious task of trimming the excess styrene. I like to use this paint scraper, which has a nice flat edge. I have an unending supply of razor blades available. Another tool I use infrequently for this purpose is my leather skiving knife. This knife is unreasonably sharp. Here I'm using a strop design courtesy of Outdoors 55. Cheers, dude. Altogether, what you see here represents most of the ways I have available for myself to make stuff. Before assembly, there is the requisite and wholly unavoidable work of finishing each piece. My go-to tools are sanding sticks of various widths. I'll start on the layer lines of the filament prints with 180 grit or so. I tend to use 240 and 320 grit for most work and wet sanding. I have 2 Prusa minis, and I love them. I do prefer sticks for flat surfaces. This type of sanding with paper can round the edges a little too easily for my liking. I always follow up with glazing putty. If there's no detail to obscure, I might spray primer before assembly. I found that if I'm going to mold and cast a master, the resin prints must have the support scars taken down. You could get bubbles in the resin. I'll get aggressive with sanding sticks in this case. The rest of the print gets wet sanded, usually with 400 or 600 grit. My resin printers are Mars 2 Pros, and I'm not ashamed to say. They have served me well for whatever I do, and there's always finishing and assembly, so I don't need anything fancier at this point. Maybe later. Right now, I can make chicken salad, as they say, out of chicken shit. I'm using Fixie to bond this resin print to some laser cut acrylic. After this piece is placed, I'll fill the gaps with glazing putty and then wet sand the seam. For sanding edges of laser cut acrylic, my go-to is this carborundum sandpaper, taped to a small melamine shelf. I tell you, this particular piece of paper must be nearly 20 years old. It never seems to lose its bite. Carborundum is an amazing product. I have not used CA to bond PLA prints in years. If you want to bond PLA to itself or anything else, reach for side grip Weldon 16. It makes an exceedingly strong bond. Here I'm bonding a PLA corner to acrylic, assuring alignment with painter's tape. It'll quickly form a skin, so you have to get the cap back on the tube, and you have to join your parts quickly. Clamping under pressure helps, but you really just need to let it be for about 10 minutes. This is the bottom part of the panel. It has beveled edges, I assume, for draft of injection molding. I've scored a line on the part with the laser cutter, and I have a little dust collector here, and I'm using a large carbide lab burr to remove a bulk of material. Then I'll sand the edges progressively until it's nice and smooth. Here's a trick I've learned. Sometimes, if a joint is filled with glazing putty, you just can't seem to make it disappear. It may depend on the dissimilar materials of the joint, but sometimes, no matter how much or how gently you sand, that joint is always there. What I have here is some thin CA that I'll apply with a spatula. Just run it over the putty. Then I'll place some kicker. I've never enjoyed spraying kicker, so I'll run some right atop the CA, then start wet sanding. Always with a stick over these joints. It doesn't seem to take much, and it makes a surprising difference. I left a little overhang of the styrene sheet over the windows to assure a proper finish. I'm adding some evergreen styrene here to fill these areas. Then I'll add some glazing putty and gently sand everything flush. I'm taking my time here to place the window edges in proper alignment, then I'll weight them. This is what I mean about the blue paint mask bonding nicely to acrylic with solvents. I'm using Weldon 3 in my beloved needle applicator. You may notice in other videos that I use these applicators quite a bit, most often for Weld-On 3. Sometimes when I have to use CA, I'll dilute it with acetone and apply it to the joints. It takes a little longer to cure, and I always dunk the tip into acetone afterwards. CA can cork it up pretty quickly. I ended up removing the tabs from the back of this bottom part to get a better finish of the edge. Weld-On 3 does a really nice job bonding PLA to acrylic. I've lightly primered these rear inserts beforehand. I want them to be pretty before assembly. The whole thing will get primer, of course, but sometimes it can be too much. Depending on the primer, details can be lost. I beveled the edge of this laser cut piece and I'll secure it with Weld-On 3. It's a decent fit. Gotta run. I didn't have sanding the edges in front of mine during design, so I didn't compensate for it in the laser cuts. No biggie, I just added a 0.75mm strip to one edge and finished it. I guess there's a cumulative effect that errors can have. Live and learn. For a really pretty finish on the inside edge of the rim, I precision scored and placed some thin styrene here, bonding it with thin CA. I knew this would happen someday and I seemed to push my luck, but it seems that the glazing putty melted the styrene. I didn't notice it before I used the thin CA kicker trick to finish the putty, but a little more and some wet sanding took care of it. It's interesting. This is some styrene strip to hide the edge. I whittled some styrene strip to make these things that I assume are stoppers or catches when the dashboard is affixed in the cars. These were a pain. And lastly, we have these tabs that I scratched in styrene. So here's the finished master. I'm quite happy with it. I've added some styrene strips on the inside for placement guides of other things. Stay tuned. It appears to be nice and clean, but the truth becomes known after a few light coats of primer. And here it is. First impressions are this is really nice and clean. I've added some tape over the holes on the back before primer. This keeps the silicone from sticking to the tape otherwise. The possible errors that jump out at me are this space between the windows and the rim. I think it should be larger. Also, this offset is a little thicker than in the design, but I couldn't reconcile the angles of the inserts any other way. Again, cumulative errors perhaps. Aesthetically, it's very pretty. Structurally, I don't trust it. Parts could break away and come apart too easily for my liking. I always mold and cast what I build, even if it's for a one-off. Now, to the rubber. I've made a styrene box for the rubber. I've added small brass pins to the holes and poured enough rubber to fill the windows. I closed the windows with styrene, sealed with white glue and held with Scotch tape. I was worried about the rubber seeping through, so I thought I was quite clever regarding this mini pour. My cleverness was once again outdone by my oversight in forgetting to place the keys. The solution was simple, as you can see here. The master is sealed to the styrene with a bead of white glue around the edges, plus small dots of thick CA in a few places. The white glue works well to seal, and it just peels off when demolding. This may seem strange, but I keep the ends of the rubber pours and chop them up for later use. The intention is to reduce the amount of rubber required, saving supplies and cash. New rubber will chemically bond to set rubber, becoming a more or less homogeneous mass once it's all set. One of these days I'm going to buy a sausage grinder just for this purpose. I've taped some supports to the sides of the mold box. I'll pour enough to sink some recycled rubber into. Gotta be gentle here when sinking the recycled bits. You want to avoid dislodging the master or blowing out the side of the mold box. The mold box is held together with tape, and then I place a little bit of white glue into the corners where the tape can't overlap properly. This is often enough to prevent or at least minimize rubber from draining through these areas. It's always a good idea to add as much recycled rubber as possible without losing any detail of the master. I'll pour a little more over the top to pretty it up. When set, I often try to keep as many sides of the box in place, but often have to remove at least one side to remove the tape and the floor of the box. Inevitably, there is rubber flash in some areas. To clean it, I find that a round blade can cut the flash away with minimal pressure, not even enough to scratch the primer. Having clean edges here allows better parting line, which means less cleanup of the casting. So here's one part of the mold. It's all going well thus far, and I'm having fun with this. I'm going to place a few vents. Yes, I reuse them. Why not? This is the sprue. When replacing the walls of the mold box, I've learned to place a thick bead of Vaseline adjacent to the parting surface. This works well to minimize any rubber leak into the potential void that's there. It is important to coat any exposed rubber, as new rubber will bond directly to old rubber. My preferred material is Vaseline as is. This is an ancient tub of the stuff. I've had it since before Y2K. There always seems to be enough. Once you've coated what you need to, the clock starts ticking. You gotta get the next pour of the rubber in there. I've placed the mold box on thick acrylic and tilted it. There's painter's tape holding the form of the box more or less. I don't have a lot of rubber left here, so I'm not going to fill the box. I'm only going for about 2 cm thickness above the inner surface, as you can see here. It'll be an oddly shaped mold, but it will suffice. Again, pour some, add recycled rubber, sink them, repeat. I always become nervous when hatching a mold, especially here as I've used up nearly all the rubber I have. Before I split the mold, I like to bevel the edges. Depending on the size of the mold, it could prevent distortion during casting due to the shape at the edges. Run a blade along the edges and it not only prevents the problem, it makes the mold a little prettier. So here we go. The moment of truth is upon us. Separating nicely so far. Now that's a nice parting surface. I really don't want to break the master, but sometimes you have to be a little aggressive. Okay, not bad. There's a little flash here and there, but it's nice. It goes back together nicely too. I found that placing metal pins in the mold is the easiest way to get clean, perfect screw holes in the cast. I'm going to place the mold on this melamine shelf so I can tilt it during the resin pour. I've already added actual baby powder to both sides and you can see the metal pins are in place. I'm only adding the weights to hold the halves together. There is very little vertical height to this cast, and with the keys and the weights, I'm not worried at all about the sides distorting or blowing out. Here's another instance where my cleverness succumbed to a harsh reality. The funnel I have is not tall enough to adequately allow hydrostatic pressure to get the resin to the topmost areas of the mold. This will be worsened once I tilt the mold, and the funnel will be at the lowest point. Again, the solution is not severe. I'll use an actual plastic straw to extend the sprue and get a little bit more hydrostatic pressure to our advantage. It's not awesome, but it'll work. So here we go with the pour. It may look like I way overestimated the amount of resin I'll need, but I'm pouring several things at once here today. The resin has had time to fully cure, so let's retrieve our casting. Not bad at all. Nice and clean. Only a few small bubbles here and there. I introduced these bubbles as I peeked in to check that the resin was actually flowing. Again, foiled by my own endeavors. But these little bubbles can be backfilled, and nobody will ever know. And here we have the final product. What fun this was! I guess it's fun if the project ends as intended, eh? Thank you once again for joining me. I'll use this casting in next month's project. As I've said, I'm no expert, but perhaps you've learned some tricks that could help you with your pastimes and obsessions. Likes and subscribes are appreciated, but not necessary. Just enjoy your day, and don't pass on a chance to do something nice for someone when you can. We all need more of that these days. I hope you'll visit again. Thank you, and be well.